All right, thanks. All right, so I think before we proceed with the new topic, it's a couple of clarifications on, I think, one question. So while looking at SQS, if you remember that we discussed two types of queues. One is called standard queue, and the second one is called FIFO queue. And while FIFO has like more features, like it has concept of message group as well as something known as a deduplication ID, or it can basically identify which messages are duplicate. So for this, we have used something known as deduplication ID. So that deduplication ID is actually unique within the queue, and that is not scoped under message group. So that is something which you should remember. So we looked at the concept of message group as well as deduplication ID, and we have also seen with SQS the kind of guaranteed order, or an order guarantee is guaranteed within the group and not across the various message groups. All right, I think once again, good afternoon, everyone. And let's begin with the new topic. So today we will look at something known as API gateway. And that is something which we'll use in continuation with Lambda. And we have seen day before yesterday, a couple of days back, how to use Lambda, and we also understood the concept of Docker or container. And we ran one container on EC2. We tried to actually set up an application, and we saw that how to run multiple Tomcat containers, how to run our custom application, and that is something which is very handy when you actually work with multiple kind of microservices based application. And I think one of the question which was asked on that day was, how do we actually expose our Lambda to the outside world? Can I expose it to the outside world? An answer to that is yes. And that is something which is typically done using API gateway. So let's look at API gateway. I'm just going to share my screen. All right, can you see my screen?
Yes.
Okay, all right. So Amazon API gateway. So as the name suggests, it provides API and it also provides some kind of gateway. So gateway is nothing but basically your function is running. Yes. All right. So just a gentle request, mute yourself unless you have any question or comment. So it is basically API plus gateway. So our function is, let's say Lambda is running inside our PPC, and you want to invoke that from the outside world. And that is what the gateway provides. So it provides an entry point for our function. So API gateway is a generic concept. So we are going to look at Amazon specific implementation, that is Amazon API gateway. And it is also possible that if you are using another API gateway, then you can also use those API gateway in AWS. But in that case, you might have to set up those API gateways on EC2 servers. For example, we have been using this REST-based web services, SOAP-based web services, and that is something which is not new concept, and people have been using that. So you can still go and use that, But when you work with those kind of REST interfaces and so on, the responsibility of deploying that and ensuring that your API endpoint is up and running, that is something which you need to do. So we'll understand what are the benefits of API gateway as well. So API gateway is a managed service from AWS. So if you want to really expose any API or let's say Lambda function or could be HTTP endpoint, then you can use API gateway. So there might be case your web server might be running inside a private subnet. And if you want to expose that, then you can utilize API gateway as well. We'll look at API gateway integration. We'll look at proxy as well as what is custom integration. And we'll take an example of proxy. So we'll actually set up one Lambda function in AWS and invoke that Lambda function using API gateway through proxy integration. Now there are many features of API gateway. We'll just understand as a concept: throttling, caching, authentication, canary release, and support for custom domain. So Amazon API gateway is an AWS service for creating, publishing, maintaining, monitoring, and securing HTTP, REST, and WebSocket APIs at any scale. So it basically supports three different kinds of APIs. REST was there from earlier days. WebSocket was also there, and recently they added HTTP. So earlier it was not possible to just expose our kind of HTTP endpoint to the outside world using API gateway, but that is something which is made possible now. So WebSocket is nothing but it's like if you want to build some kind of chat application, then you can use WebSocket. So the connection remains open for some time, and then server can send the response. So typically a lot of people actually using REST interface. And what are the drivers for building and using API gateway? Well, you can write your web services. You can deploy your web services using Spring Boot or some other framework, Apache CXF, or you can use any other third-party kind of framework. But the benefit of API gateway is that don't do undifferentiated heavy lifting. And that is the message which is this provided by AWS as well as many cloud providers. So what AWS is saying, you just focus on your building the application functionality. Don't worry about managing the infrastructure. See, we have looked at some of those services like S3. See, when we look at S3, we just upload the content, we upload the bucket, create the bucket and upload the objects. Now we don't create a server where we are accepting the files using FTP protocol. We don't maintain anything. We don't really have to worry about underlying infrastructure. If you look at DynamoDB also, it's like we are not maintaining any servers. Same goes with Lambda. Same goes with RDS. So what is happening is that we know that development is becoming more and more complicated. Even it is becoming easier, but nowadays people are expecting a lot of complexities, complex applications. So instead of focusing on building this infrastructure, and which is a undifferentiated heavy lifting. So in the sense, your focus should be on providing value to the customer. So you focus on the business side, focus on the application and so on. So that is the same thing which is provided by API gateways as well as many other services by AWS. So you can put multiple versions and you can put a staging multiple stages. So you can do a development API. You can say that I want to expose this API as a development API. I want to expose this as a beta. I want to expose this as a production. That is something which you can do. You can monitor access to third-party developers. You can use something known as API keys. For example, if you used any third-party kind of APIs, then most of the time they will give you some kind of a key, which you need to provide while invoking those APIs. So that API keys identifies, let's say, who is the kind of or who is the entity. So that is which is provided by this API key. And behind the scene, they might provide you some kind of limits. So they may say you can invoke this APIs only every 20 times per minute. So if you want to invoke those APIs beyond 20 times a minute, then you need to pay us. So that is something which which is kind of a typical usage of API. Access authorization, you can do authorization. In case there are traffic spikes, the API gateway is going to automatically scale for you. And going serverless, move away from servers. And there are some other benefits like you can validate the request before processing it onto the backend. So let's say you want to ensure that request parameters, if you are accepting, let's say, first name and last name or username and email, and you want to ensure that that parameter is always specified before I pass it to the backend, then API Gateway provides some validation features. So if the request does not include those parameters or headers, then it is not going to pass it further. It is going to reject it at the first call itself. So this also enables you to simplify your coding logic. And that is something which is another benefit of API Gateway. One more benefit, it's called response caching. So if you see that a lot of times the same kind of requests are coming. So let's say if you are querying, let's say give me the most popular videos or give me the most popular books. And that is something which if it is coming often, then you don't have to really go to the backend and get the data again. So you can basically do the response caching. And that is something which is configurable in the API Gateway. So the benefit is that it provides reduced latency to the caller and also it reduces the calls made to the backend. So some of the benefits of API Gateway. So many API Gateway gives you these kind of benefits plus extra added benefits. So that is the kind of reason why people are moving to API Gateway. So it supports WebSockets also. So we know that REST API and HTTP how it works. So whenever you are making an HTTP request, then it is going to open a connection and close the connection for every request. And it follows kind of it basically requires a connection, but every time it has to make a new connection. So that is something which is not really good for many applications where you are building applications like stock ticker, real-time dashboards. For example, if you basically doing trading, etc., then you know what is the importance of it. So your application is opened up in a web browser, and then every time you go to the backend and you get the kind of latest stock price, by the time you get the result, somebody has already made a big kind of a transaction, and you might lose that opportunity of actually doing that transaction. So it is very helpful in real-time dashboards, stock ticker, chat rooms, real-time alerts and notification. So that is something which is supported by API Gateway. So it's a very simple concept. Architecture. Let's look at the architecture. So you might have your Lambda function. Lambda might internally talk to DynamoDB. Then there might be an EC2, S3, and so on. So there are various ways in which you can expose all those things internally running resources. So it is also possible to expose S3 via API Gateway. You can also expose DynamoDB via API Gateway and so on. It's like we have seen some examples with DynamoDB. We looked at music table. Then we said that I want to basically search on this particular artist. So if that is something which you want to expose, well, you can straight away expose that using DynamoDB and something like that. So your application is going to invoke the API, and the API Gateway interacts with the internal services. So this is a model for REST-based interface. So what do you do in the REST? So in the REST interface, it basically is nothing on. It's basically built on top of HTTP. So it just uses get, post, put, delete, options, head, all those kind of methods which are there in the HTTP protocol. And you will kind of get some resources which are running at the backend. So if you want to just get the contact, so you just say that get contact. So invoke a get method and pass the contact ID. You can pass depending on how it is designed. You can pass first name, last name, or email. If you want to insert any data in the backend, then you might say post and so on. So that is the way you basically use this REST APIs. And once you kind of provide these APIs, now API gateway, let's say you provide the API gateway to invoke your Lambda function, then your application needs to invoke your API gateway. So if you're using mobile app, then you need to invoke those API gateway using SDKs. If you are, you can use Java SDK, you can use many SDKs. So you can straight away use these API gateways. You can use Postman client just to invoke your API gateway for testing purpose and so on. And this is what happens behind the scenes. So API gateway can cache certain data. So you can basically define what is the cache size and so on. So obviously it is going to charge you additional because it's not free. And Lambda functions, EC2 endpoints, or it could be any other endpoint also. So you might write a Lambda function which is interacting with, let's say, on-premise endpoint. So that is also possible. Any question? Okay, so just to give you some key kind of definitions. So API is nothing but the collection of programmable entities, resources, and expose methods. So you can write an API saying that get incomes, put expenses, and each resource can have one or more methods. So you can say get me an income for this particular person and so on. Okay. So what we will do right now is that it is much easier to understand from looking at the AWS console. So let's go to AWS console. So if you're doing this with me, then let's log into AWS console and let's see this in action. All right, so if you go to this demo labs workshop, now I provided you a link. So if you just go to this link, just click on this link. This is on page number 25, 26. Yeah, it is on page number 26. So if you just click on this link, so this is just to illustrate the concept. So once you understand the concept, then you can build the logic easily. So this example we are going to look at is called exposing Lambda using API gateway. And API gateway is integrated with proxy integration. Proxy means whatever you get in the request, just pass it to the backend. So for this, we need basic two things. One is called Lambda function. So what this Lambda function does, it is going to greet you. So what it is going to do is that it is going to say greeting. This is the message. It is going to say good, time, name, city, and day. So all the things which are shown in the red, that is something which you are going to pass as a parameter via API gateway. So that is something which we are going to set it up. So this Lambda function sample code is there, and we are going to use this particular code. And this is in Node.js. So it's very simple JavaScript code. So it says console.log loading hello world function. Exports handler. So this is the handler function which will be invoked by Lambda service. So whenever there is an event, it is going to invoke this. And event is going to be our API gateway invocation. And it initializes some variables, name variable, city, time, day. And the response code is going to be returned when it is going to be successful. And what it is doing, it is basically extracting this event object and looking for query string parameter. So when we are invoking any, let's say HTTP based URL, then we can pass query string parameters. So it is going to invoke, it is going to parse this event and find out the name. So name is kind of extracted. Similarly, it is going to extract city. So we are going to pass this name and city as a kind of parameter, and then a day is passed as header, and then the time is passed as a body in the body. So this is just to demonstrate how to pass various parameters and extract using the code. And then it is going to construct a greeting message. It is going to say good. So whatever the values which you're going to get, just put the values, and it is going to give you the response. And it is basically going to construct a response body. And when we actually use Lambda proxy integration, then we have to conform to specific JSON object. And that is why this response is configured in such a manner. So status code is response code, headers, custom header, and then body JSON stringify response body. And then it is going to return response. Also, it is going to log the response to the console. So when we are going to use the console, it means it is going to use CloudWatch. So very simple code. So let's dive into console, and then we will actually create this Lambda function, and then we will create a Hello World API. Now nowadays AWS is improving the console interface, so a lot of things are actually happening at the click of the button. So, but we will focus on how to actually use this API gateway from scratch. Okay. So let's go to this Lambda function. So I'm going to go to Lambda. All right, so let's create a function. So did you manage to get that link? Those who are following with me, along with me?
Yes.
Yeah.
Okay. So just create function. Now last time what we did, we basically created function in Eclipse and uploaded the function in using Eclipse. So I think some of you got that code working, and that is one way of doing it, because that's basically Java world, so you cannot really write code directly over here. But in this particular example, we are going to use JavaScript, and it supports a built-in editor, so you can straight away code it over here. So give a name. So I'm going to provide a name. So this name is going to be, let's say, Amod JD API demo function. So typically, when you are actually building any functionality, you will have a specific functional kind of name, maybe authenticate function, maybe file processing function, something like that. Runtime is Node.js. So what happens when you use this Node.js as runtime? Behind the scene, it is going to use the corresponding Docker Node.js image. So it is not going to set up Node.js on the container when you actually execute this function. It is going to use the existing Node.js based image. Choose or create an execution role. Now this is something which you can use existing role, or you can also create a new role. So it is not necessary that each Lambda function should have a different role. So if the Lambda function is basically using the same kind of services, then you can reuse the role. So you can create a new role with basic Lambda permission, that is also fine. And I'm going to use an existing role. So basic permissions are nothing but, it should be able to log these details. It should be able to use the CloudWatch. It should be able to create log stream, log group, and so on. And I say create function. So this function is created, and let's put the
So
code.
we have to
Copy paste the code.
Yeah. Sorry, Amod. After choosing the execution role, use an existing role. Do we need to select anything? I think you kept it blank, right?
No, basically in my case the role was already there. So what you can do, you can create a new role if you don't have a role.
Okay. I do have two roles which we have created in last session.
Okay, so what is the name?
That AWS training hello function.
What is the name of the role?
Wait, service hyphen role / JD AWS training hello function.
Okay.
Role hyphen then 9CVX DC5D.
Okay, so what I suggest, you create a role, because I don't know
Okay.
what permission that role is having.
Okay.
You just create a new role.
Yeah. Lambda permission with.
Yeah, Lambda permission. Yeah. Should I repeat that?
No. Okay, I have created.
Okay, fine.
Thank you.
So just select the function and just scroll down. You will see, you'll get a nice editor, and just copy paste the code which is there in the site in this particular link. So I'm just going to copy this code. So luckily there is a copy here. Just click on copy and paste it inside your Lambda function code. And click on save. Don't forget to click on save. See, ideally when you are developing this Lambda function, you should be actually testing this. So for that you can configure something on a test event. But for this we are going to rely on it directly because it is something which is provided as a tested code. So we assume that it is going to work. So that is the part one. Now let's do one thing. Let's create an API gateway. So you can actually create an API gateway from here also. But this is going to hide a lot of things because it is going to do a lot of things automatically for us. So instead of using this, we will go to API gateway service. So I'm just going to open another tab.
So sorry to interrupt you again.
Yeah, go ahead.
Actually, in editor, I think it is not loading anything for me. So I'm getting error, unable to load this.
Just click on this.
Yes.
Scroll down. What do you see?
So yeah, for the in the editor, I'm getting in function code, I'm getting that continuous loading thing, and once I got the error that unable to load .zip file from the console.
.zip file.
Yeah.
No, have you created a new function or you are using the existing one?
No, I have created new function as you said that I have selected for first option, that create new function with the basic Lambda permission.
Okay. Do you see anything like index.js on this left hand side?
No, it is not loading the tree at all. That I'm getting that 3 loading dots.
Okay. Just go back to Lambda and just try to navigate to the same.
Okay. So in function code, it is saying loading your function.
If you select function, so let me select yeah, sometimes it can happen, but you have to just retry it. Are you not able to load it again?
No, it is not loading. I'm getting the same error. I think on Friday session also I was not able to see the anything in function code. It was giving me the same what I'm getting now.
So it is loaded now.
No, not yet. It is showing the same 3 dots loading. Shall I create a new file or
Yeah, you create a new function altogether. You are in which region?
Mumbai.
Okay. And I presume that you are having enough rights, permissions, but there should not be any permission issue per se. So you are using root user email ID or you are using IAM user?
Root user email ID. I'm in a root user.
Then there is no permission issue at all. So most likely, otherwise, what you can do, you can use switch to another region. Let's see. You can switch to US East, North Virginia, and just try that again.
Sure. I will do that.
Yeah, sometimes it could be a challenge working with console because this AWS management console is not the best UI out there because
Okay.
there's a lot of kind of positive, negative reviews about console, and they have given a lot of services, and their main focus is on just to give you features, raw features.
Okay.
And sometimes the UI is not the best way to work with AWS.
Right. Because previously also I was getting the same error. Okay, because I think Friday also we have created some Lambda functions for the SQS
That's correct. Yeah.
session. So that day also I was getting the same error. So okay, I will change the reason and I will try to
Try
create.
changing the region. If it does not, then maybe you can log a support request.
Okay, fine. Sure.
I hope your account. So your account is recently opened or is it like old account?
It's a kind of old, means quite old, but not expired. It is still in period here and have a lot of time.
Yeah, so I don't think there is an issue with activation because sometimes when you open a new account, then the activation process takes a little bit time.
Okay.
So especially with India, they actually started calling up people and started verifying also.
Okay.
So just
fine.
try with, yeah.
So I'm creating in North Virginia.
That's fine. Okay.
So the node function, new rule with the basic Lambda permission.
Basic, yeah.
Okay, so function is successfully created.
Okay.
Let's see what I get in function code.
Is it loading?
It's loading, but still I'm not getting anything. I'm waiting that load get finished.
Okay, ensure that you click on this particular function.
Yeah, sure. I will. So you can continue. I think it is not.
If it doesn't work, then we need to take it offline.
Sure. Okay, in a rest session.
Yeah. Okay, so I want to create now REST API or API gateway. So I will go to API gateway, search on API gateway. So in my case, there might be a number of APIs. So depending on your usage of API gateway, if you have not used it, it should be blank. So let's create API. So let's create an API here. You just click on API, and it gives you kind of options. What is the API type? So we are going to use REST API. So I'm going to create one. You can also import it from Swagger file and so on. I can just create a build file. So they keep your UI changing. So whenever I work on AWS, every time I find something new. So choose the protocol REST, create a new API, new, and I'll give a name. So I'm just going to give a name, Amod GD demo API. Description, using API gateway to invoke Lambda. And endpoint, now there are different endpoints here. So one is called private. So private API is obvious is that it is accessible only through VPC endpoints. So if you want to create an API internally, let's say there is a web application, and the web application in turn passes the request to your API endpoint, and you want to keep it private. Then in that case, you keep private. Other is regional, so we're going to reuse regional. So regional meaning those are deployed in the current region, that is in Mumbai, and there is one more which is called edge optimized. So what is edge optimized? So edge locations are, there are many edge locations. I think we have seen on day one what is edge location. So when you are going to use edge locations, then what is going to happen? Your API will be available over the edge locations. So there are many edge locations. And they keep on adding. So edge location is basically a location which is different than your region. So if you look at this particular screen, then we are in Mumbai region. You see a regional edge cache, and then you also see the dots over here, the blue dots, and there is a purple dot. It means there are some edge locations in India. So what is going to happen when your API gateway publishes the API, then that API endpoint is going to be available over here as well. So if the user is coming from, let's say, this part of the region, then they will actually hit this endpoint. Somebody is coming from down, then they will hit this endpoint. So that is called edge optimized API endpoint. And that is something which is really required when you are actually having, if you want to improve the kind of, latency, which is kind of, for the users and so on. So right now we are going to use regional. So it will be sitting inside the region, Mumbai. It means it is going to deploy in those AZs. So in fact, it is going to run in somewhere in Andheri East.
So edge location cost us more?
I don't think so, because I think I need to check. Generally, yes, but for API gateway, there might be an exception.
Okay.
Yeah. So let's say create API. So this UI is not really great. It is a bit confusing at times. But what is happening over here is that it is showing you the UI. It's the resources. These resources is kind of, nothing is created. So if you just go to our documentation link, then if you just scroll down, so we are just following these instructions. Create a new API, choose new API. We have given some name. Then I can give a resource name. So resource name is, in this case, is hello world. But it could be, in reality, it could be contact and so on. So I'm just going to say create resource. So this is my resource name, hello world. And what else? So if I just go to this and just create resource, that's it. We don't have to do anything else. So I will just click create resource. So this resource is created. Because what we are trying to do, we are basically trying to expose our Lambda. Now I want to expose my Lambda function, and I want to expose, this is a REST API. So I'm going to create a method. So I'm just going to say, I can just say get. You can also choose other API methods also, depending on your requirement. So you can also use any method. So if you look at all these kind of HTTP, you can also say any method. So any method which comes to this particular resource, I just want to configure that. let's say any. And then what is the integration type? So if you look at this, then you can integrate this with Lambda function, you can integrate with HTTP, AWS service, and so on. And then it is also providing some mock, so you can just write some kind of mapping. So you don't have to really write code, so it is useful for testing purpose. So in this case, Lambda function, and then use Lambda proxy integration. You have to just ensure that you select this. Request will be proxied to Lambda with request details available in the event of your handler function. So it is going to pass all the details. So it is not going to filter anything. So it's proxy. And if I just come here, now somehow there is an UI issue here. So if you don't see any Lambda function, start typing here. So there are two functions. I'm going to select this one. See, if you don't see this, what you can do, you can go to Lambda and copy the URL of the function or the ARN. So this is my function. So if you see ARN here, Amazon resource name, I can just copy this and paste it over there. That is also possible. Okay. And click on save. And it is saying add a permission to Lambda function. You are about to give API gateway permission to invoke your Lambda function. Now remember, even if the service is defined by AWS, it does not have implicit permissions to invoke our Lambda function. And that is where the role concept comes into picture. So it is going to give appropriate permission. All right. So this is another kind of screen which pops up. So this is the it says method request. So what happens is that when the API gateway is going to get a request, it will come to this as a request, and then it will be passed to Lambda. Here, if you see Lambda here, so you have to just tilt your head a little bit so as to read it, and then it is going to execute, give the response back, and this basically will be provided by API gateway back to the caller. And we can test it. So I can test this. I can go to client test. I'm making a test call on your method with the provided input. So far what has happened is that our Lambda got connected. So in this case, so we have created Lambda function. And we are creating this API. We have created this API gateway. And we have made a connection to this. So let's test this. And what is the code which is inside their Lambda function? We have to pass two parameters as a query string name. So we are going to pass name as a query string. And also I'm going to pass city as a query string. And then I can pass day as a header. So this will be passed as header. And this will be passed as query string. And if you want to pass the time, then time is passed through body. And this Lambda is going to give the response back based on the pass parameters. Now we are using get right now, so we cannot pass body there. So let's see. So I'm going to use get. So no path parameters exist for this resource, and I'm going to just pass parameters. So name is equal to Amod and city equal to, let's say, Mumbai. And header, I'm going to use day. Day is Monday. So this is the way you basically, this is just nothing but test client. You can invoke, you can use Postman also. And I say test. So when you do test, what is happening? You are getting a response back. See, if you look at this one. So good day, Amod of Mumbai. So if you look at this one, Amod of Mumbai. So these basically are parameters which are passed through our API gateway. And if you look at this request, hello world, name, Amod, city, status is 200, latency 303 milliseconds. So this in turn has invoked our Lambda function and is giving you the response. And you can verify that by going to Lambda function also. So just I will take a and pause here. Those who are trying, are you getting this?
I'm getting hello from Lambda as a response.
No, then I think you have mapped your Lambda function incorrectly. So you should map your API gateway to the Lambda function which we just created, not the one which we created on Friday. So just go back. Anybody else got it? Somebody else said yes.
Yeah.
Yes, sir.
Okay, all right. This is very straightforward. Okay, so I can go back to my Lambda, and if I look at my monitoring tab, okay, before that, let me refresh my Lambda screen. See, if you look at this, our trigger here, the trigger automatically appears now. And if you remember our kind of, the Friday's kind of, session, then we have added this trigger explicitly. So that is something which is done. And then if I look at my monitoring tab, and so let me check which one. I should get some details there also. So this is my GD demo. So I'm just checking whether I'm getting any logs or not. So it is not appearing, but we have seen that it basically has given me the output.
I am able to see the logs.
Yeah, you should. I don't know what is the issue in my case. Let to see. You should actually, because we are logging it there, it should create log files. Okay. So this is what the way you basically work with it.
So
if you,
I have one question here.
Yeah.
So here we can see in Lambda there is a trigger like API gateway. The same we followed on Friday, like we had trigger as a S3 event like that. Suppose I am running one REST APIs which is running in Lambda. So every case, suppose I am hitting REST APIs which are running in Lambda using Postman. So every time the event type will be API gateway only.
No, it will go through via API gateway. If you are hitting the API gateway,
Suppose
then the API, yeah.
Suppose it is always like that. We should have API gateway to hit the REST API, or we can omit that one.
No, the Lambda is actually, if you want to expose Lambda, then you should actually use API gateway as a best practice. See, because the endpoint is not publicly available, right? So Lambda is basically within your VPC, so not VPC, in your AWS account.
Okay.
So if you want to invoke your Lambda function directly, then you need to have appropriate permissions so that you can invoke Lambda function directly through API or through CLI. That is also possible. But that is not going to be REST call.
Okay. In Eclipse, I saw one option also, input type as a stream request handler. So what it does, that is important. Just like we have input type S3 event and all. I saw stream request handler was also there. So in what cases we can use that?
For Lambda, you're saying?
Yes, that means input type we have to select in Eclipse whenever we are creating AWS Lambda Java project. That time you provide the event type, like suppose we are providing S3 event. Now in this case our API gateway, but there is option of stream request handler as well.
That's correct. We see if you look at when you integrate with DynamoDB, then if you want to integrate with DynamoDB streams, stream means like it's continuous data. Okay, so if you want to integrate with, one second, let me pull that up. So if you have this, so these whenever you are working with DynamoDB, then in that case you have to say it's basically stream.
Okay.
So in that case, that particular event will be a class of that particular stream. What you are saying.
It can be Kinesis as well, right?
It would be Kinesis. It could be DynamoDB. Yes, that's correct.
Okay. Okay, so we cannot create just like we did it through console in Eclipse. We cannot do like choosing the event type like API gateway and create the project.
Yeah, you can create. You can create like if you go to Lambda, so you can just choose the trigger here. So I just don't want to break this, but it's add trigger. It is also possible to. There are many kinds of, if you look at this Kinesis, you want to use Kinesis, then you can connect to Kinesis.
Okay. Through console, okay, we can do, but I didn't see any option in Eclipse. Okay.
Yeah, console, anyway, you have to set it through either console through CLI. But when you're writing Java code, you have to basically write appropriate handler event function. Okay, so now this particular function is API gateway is there, but this is not exposed to the outside world. This is still running within our AWS account. So what we need to do, we have to basically deploy that API. So when you say deploy the API gateway, it means it will be available to the outside world. So let me go to my API gateway back. And choose the API. And let's say I want to access this API over the browser. So in that case, I can say actions and I say deploy API. And you say deploy API, you choose a stage where your API will be deployed. The stage is nothing but you have to give a name. It could be development stage, it could be prod stage, and so on. So I'm just saying deploy this API and put this as a stage dev and say deploy. And once you do deploy, you will come to the stages screen. There is one more kind of in a screen, stages. So those who are doing it, they should also get the similar screen. And it is going to give you an endpoint. So HTTPS something execute -API AP South 1 AmazonAWS.com/dev. So let's see whether I can invoke this API through browser. So I want to invoke this. So I'm just going to copy this. And then my resource name, I need to append the resource name here. So I'm just going to copy this. And my resource name is hello world. And I'm going to pass parameter as first name, no, sorry, name and city. And hit enter. So I'm getting some output here. Now I may have some plugin setup. So anyway, there is not plugin is disabled, but you should get this kind of output from the browser.
Amod, here I do have one question.
Yes.
I think previously someone said that she got the hello world from Lambda as a result.
Correct.
Okay, so I am also getting the same result, but I have questions. So I means after getting that result, I created another request, Lambda request API gateway. Okay, in that I specifically choose the function which we just recently created, that which I have named as JD AWS training _ API _ demo function. Okay, and in that function, I'm also able to see the API gateway which I have created just now. Means two API gateways. Okay, or that one is the any and another one is the that one get. Still, I'm getting the hello lambda, hello world lambda kind of output.
So Ranjit, I was also getting the same. Even I was able to see the trigger also. But just try and save that file once and then hit the test again. I got the output. I
Okay,
guess you
so
did not
maybe
save.
yeah, I have saved, but maybe I think I do have a problem with my editor. That's why maybe I'm facing the same. Yeah, because my function is still not loading. I created a new file, so that is also not loading.
So North Virginia.
Yeah.
Even in North
So
Virginia.
yes. I think my
On which browser you are using?
Google Chrome.
Okay.
So maybe my account has problem related to that. I need to create a service or request, raise and request for the same.
Yeah, just try, but sometimes even I do get it, but generally it gets sorted. So,
No, actually
there is
on
the
Friday, actually on Friday also I was getting the same because I created through 2-3 times. So it was not loading. So I thought that it might be some problem, but today is also I'm facing the same problem.
So you might actually just try it again if it doesn't work.
Yeah, I created new file. I saved that file. I am able to see that file, but when I clicked or try to open that file, it goes into the continuous loading things.
Loading. Yeah. Yeah, might be some issue.
Yeah.
Okay, so now if you go to browser, do you see this API here? No, you see the result here. So it's a very simple mechanism. So what has happened is that we configured this, we tested it, and then finally we deployed this. So when you deploy this API, it creates a public endpoint. And it's a public endpoint, like it is available over the internet. And then you can just pass the appropriate parameters, invoke the appropriate resource, and that's it. So this is the way the API gateway works, and it is completely seamless. And you don't have to really, worry about installing your APIs and so on. It's simply available. So that's the way the configuration works. So having understood this, there are various kind of features. Now this API is something which is, if you look at this, we have created a stage. So I can create multiple stages. So this is my development stage. So if I look at my settings, then you will see enable API cache. Then there is a, if you do this, then you have to specify the cache capacity. And if you look at the cache size, it is pretty big. Even you have 237 GB of cache size. And which elements it is going to cache? That is something which we can configure that while configuring our Lambda function with API gateway. Then we have throttling. So with throttling, you can basically control the rate. So if you're in development, you want to control the rate. So I want to control rate of 10 requests per second. I want to burst. Burst means like if there is a sudden spike, then to allow 100 requests per second for burst. So that is something which is very handy with API gateway. And you can really control, the rate of request and so on. Now this is something which is very useful if you want to control the request to the downstream resources. So whatever resources we are invoking through Lambda or at the backend, those are called downstream resources, because APIs might scale, but your downstream resources might be a bottleneck, especially when you are working with database and so on. Now there is also concept of authorizers. See now here, this basically Lambda, this API gateway is publicly available, and there is no authentication is into place. Okay. So that is something it's also possible to configure. So when you go back to this one, if I can also create, if I want to create, I can create one more method, say get, but any is going to supersede. I'm just going to say get Lambda function and click on save. And then when I say when somebody is getting it, I can configure it. So if I go to my method request, so if you look at some parameters like auth, I come here and I can say what is my additional parameters. I can go inside the method request. Authorization is none. If you want to authorize using AWS IAM, you can place AWS IAM. See, when you do this and publish your API again, what is going to happen? This API will not be accessible. So if somebody goes to this particular link through the browser, that will not be allowed, because now it requires IAM authentication. So unless you are an IAM user, you will not be able to execute that. Now these are only two authorizations, but that may not be sufficient always. So in that case, there is a notion of something known as creating custom authorizer. So if you look at this section like authorizers, you can create an authorizer here. And when you can create an authorizer, and you can create an authorizer using Lambda function as well. So I think for another API I have that is already configured. I will just open this in another window. So that is something which is possible. So you can authenticate, you can build authentication logic. If it is a custom authentication logic, then what is possible is that you can create your logic in Lambda function and invoke the Lambda function. So if I look at my other API, so if I go to this inside, if I look at this, I have basically created one authorizer, which is called demo Lambda authorizer. So that is something which is created using authorizer screen, authorizer section. So this is nothing but the Lambda function. Okay. So this Lambda function is created, and this Lambda is basically saying, in this case, I'm going to use these kind of parameters to identify as an identity source. Now, this is just for demonstration purpose, but you can actually put your kind of any logic inside the Lambda. So if I go inside my this particular Lambda function, I hope it is still there. So let me go to Lambda. Okay, fine, it's here. Okay. So there is one function which is there in my case. So what you can do, you can also write your own function, and you can build some logic over here. So even if this function could be, in this case, it is going to get all the event event as kind of it will get all the data as event, and then you can extract the parameters. So if you are basically somebody is passing, let's say, username and password, then you can extract those parameters and you can write the logic over here. So in this code, you can connect to a database. If you want to connect to an let's say DynamoDB, if you want to use your own mechanism to authenticate, you can do that. So that is called custom authorizer. And when you actually do this, then you can depending on you can say that either it is unauthorized. So you can basically say unauthorized, or you can give us something known as a set of permissions. So typically you create a policy document and completely return that policy document to the caller. And based on that, then the appropriate permissions will be granted. So that is called custom authorizer. So that is also another feature which you can use. But for that, you have to really write an additional code. So let me go back to this presentation. So we have seen APIs. We can write get, put, post, and all these APIs. And we also seen API stage. So whenever we deploy any API, it goes to a stage. If you want to deploy it again to a new stage, you can do a new kind of stage configuration. So the stage can allow you to define, what is the request rate, what is the throttling rate, and so on. That is something which you can control at the stage level. And also there's another kind of benefit of stage is that if I just go back to API gateway, you can also pass some variables. So for example, we have seen in Lambda, there is a concept of environment variables. But let's say you want to pass some database connection, or you want to pass some, let's say, third-party URL to which our backend code should connect. Then you can pass that as a stage variable also. So there are stage variables you can create. So what happens when you actually create the stage variables? Those are passed when passed to the backend. So let's say you are basically you are using a development API, and for the development API you should be using some development endpoint. So you can pass those as development endpoint. So suppose if you create one more stage, so you can simply go to your API and you can create one more stage. I will deploy it again. I say deploy API. I say new stage. this is my prod stage, prod environment, and it's a deploy. So you'll see there are two stages here, and these are two different URLs. And I can pass some variables to stage variables, like I say add stage variables, let's say prod, my let's say business app URL, and you pass something like HTTPS something, another business app dot something like that com. Something you can set it up like this. So that is what this allows you. Logs and tracing, you can enable CloudWatch logs, you can enable access logs logging. Then you can also do generate SDKs. See, like these APIs need to be invoked using SDK. So they have given you convenience features where you can download the code. So you basically that code is downloaded, and you get a sample code for that, and you can just include that code in your application, and you can invoke the API gateway. Because when you are working with API gateway, then you need to do this request, sending request, and getting back the responses. So that mapping has to be done, and that mapping is kind of very easy when you are actually using these SDKs, because it is going to give you all the objects and so on, so that you can work with your programming language model. Otherwise, you have to just use REST APIs. You can use Postman or some other tool just to hit the APIs. Now you've seen how to create an API. So this is something which we have seen for proxy integration, but there is also another integration which is called custom integration. So just let me show you. Yeah. So there are some differences, like in the proxy integration, it's simplest. Entire request is passed to the backend. Now, if you are basically doing some kind of custom, so you're not passing all the details. You expect that okay, the user can pass anything to API gateway, but further I'm going to pass only certain fields. So in that case, you have to provide something known as you have to provide something known as a mapping template, and that is something which you can configure again going to API gateway. So one sec, I will just show you one sample here. All right. So if you look at this particular sample, then your API gateway, somebody is passing, let's say, XML document, and that API is passing some XML document, and then you want to convert that. So you can convert from JSON to XML and vice versa. So this is basically API gateway is going to say hello, pass this message as hello world, and then you can write some kind of mapping template. So that mapping template defines how this message is encoded from this XML to this JSON document. So it provides you some mapping features which you can use. So if I go here, then you can also pass some additional information. You can pass HTTP request headers, you can pass request body, and so on. So that's basically typically you work with API gateway. And there is one more thing which is called API keys and usage plans. If you go here in the section, so let's say I want to give you permission. Let's say you are sitting there, and I want to allow you to actually invoke my APIs. Then what I can do, I can share this API key. So I can come here and I create something known as API keys. And this API key, this I will share. So this I will share in a different way. I will share maybe through some secure mechanism. So I know that you are actually going to use this. So I can identify who is calling. And secondly, I can also create something known as usage plan. So if I go to my usage plan, so this usage plan is going to say, fine, so this is my usage plan. And so I'm allowing only 50 requests per second. You can burst up to 500 requests per second. And there is a quota of 20,000 requests per month, and so on. And this is basically I can associate with specific API and specific stage. So I can create this plan, and I can say I am basically associating with different API stage. So there might be different APIs. So this is my API. So this is my dev, and I'm just going to save it. So what is the benefit of it? This is that you can create a different kind of classes of service. For example, if somebody is saying that I'm in free tier, then you can only request with certain rate. But if you have a paid customer, then you can create different API keys for them and different usage plan. And say for paid customers, I'm going to increase this to maybe 100 requests per second or 1,000 requests per second, something like that, or burst up to 5,000 requests per second. So this way you can give this kind of functionalities to your application. See what is happening here in this case. The benefit of this model is that there is no code change. See, otherwise, if I say that, OK, I like your functionality, expose with me API. But if you want to provide this kind of features, then it is going to be difficult in your application code to manage that. And ideally, you should not do that. As a best practice, as a best design or architecture practice, you should isolate that to another layer altogether or another service. So that is where the Amazon API gateway comes into handy. So that's basically about this API gateway. So there are many features like authorizers. You can use Lambda authorizer. You can also use something known as Amazon Cognito, which we'll discuss in a couple of days. So that's basically the features of API gateway. So you have seen usage plan. You have seen API keys. So API keys, I think silver, bronze, gold offering. So typically, if you work with these payment gateway companies, or even some of the Google APIs, they might give you some quotas and so on. So that is the way you can control that. I'll stop my screen sharing for a minute. Any questions so far on this?
So Amod, we can also host our own API, right? Which we have created outside, means outside the AWS, and we can just import and place it here.
Yes.
Okay. So for authentication and authorization, I think in a world like us, we are using the Okta 2.0 kind of things. So that thing is also possible here. Means we can integrate that thing in AWS also.
No, I'm not familiar with this Okta 2.0. So can you brief me something about that? What is it? How it works?
Means it's a login authentication kind of. It's a request token kind of service where we
Okay.
have one secret key and client key, and which uh, uh, helps user means which helps application to authenticate the user with the help of means with the API means whether means the authenticated user is calling the API or not kind of things.
Yeah, I think that is possible. But you need to figure out the exact mechanics for that. What's the kind of
Okay.
steps and so on.
Okay, because you just mentioned here authentication, you can create an API key kind of things, and API key will use to authenticate the user whether authenticated user is accessing the API or not, right?
Yeah, the API key is actually may not be necessarily used for authentication.
No,
But
but
it might
for
be used
accessing
purely
the
for
API.
identification, like,
Okay.
So depending on, like, if there is a quota, then only those API keys will be allowed, or those API keys will be only using that. So
Okay.
it's not per se authentication per se. In one way you can say that, but it's more for identification, so that the appropriate quota can be checked against that.
Okay. And what if for example, if we have an application, okay, which need user to logged in, and on the basis of that, user is going to access the API. So in that kind of scenario, what thing we have here, I mean, in AWS, means like protecting the API, or they having only valid user who has logged in into the application get the access of the API.
Not logged in. Basically, typically we use Lambda as an authorizer, or you can use Cognito. So these are only two integrations which are provided by AWS.
Okay, okay.
So just share my screen. But that is, if you want to really do that, then you might have to do that outside before actually giving access to the API gateway. So you might have to do that check outside the API gateway.
Okay, okay.
But when you actually use Lambda, Lambda is basically could be a way to actually integrate your other mechanisms. But if you look at these authorizers with API gateway, you can straight away use Cognito. So Cognito is nothing but identification kind of authentication service to identify user. So that is one mechanism of the Lambda. So once you actually have Lambda, it means most likely you can explore how to integrate whatever you are doing there. So that might actually address your requirement. Apart from that, there is nothing here. So you can't really add any kind of third party here. So that is not something which is built in.
Okay, okay. Is Cognito is for the mobile only, or it is available for anything? Means like a web and kind of other things also.
No, it is available for web also. So we are going to cover that as well. But the Cognito is, let's say you are building an application for mobile app, or let's say you're having a simply serverless application, which you might write a simply HTML JavaScript application. In that case, also the Cognito can be used, and it is not really limited to mobile app. So you can use otherwise also.
Okay, okay. Yeah.
Cognito has kind of, for example, in many applications, everybody creates this user database like user table, group table, and so on. You capture the same details like first name, last name, email ID, phone number, forgot password functionality. So all that functionality is provided by Cognito. So once you configure your Cognito user pools, and it gives you an API. So you have to just invoke the API as appropriate. So you don't have to worry about creating set of tables in your database. So you can leverage that Cognito and authenticate against that Cognito.
Okay.
That is something which is kind of typical practice.
Okay. Great. Thank you.
Yeah. Okay. So that's all about this API gateway. Just trying to pull one example where I could show you model. So maybe I will show it tomorrow. This I need to just verify a couple of things here, but it is also possible to. I'll just discuss this model tomorrow. So that's about this API gateway. Is very simple functionality and it is very powerful. So most of the time people use with integration with HTTP or REST API, but it is also possible. Let's say you are hosting something on EC2, and then you can use that Lambda function. It's not Lambda API gateway to pass directly to your HTTP endpoint. So if you have an EC2, it's an EC2 server. Then I can configure my API gateway so as to expose whatever is there. So it could be simple web application. So that may not be a providing REST interface. So this is non-REST. So this is simple HTTP. So that is something which is also possible. And the third method is something like WebSocket. So all right, so that's all about this API gateway. And then we will move on to, I just want to explain a couple of more points on Lambda before I move on to another topic. So I think we saw Lambda on that day, but Lambda has many features. So one of the features I just want to talk about is something known as layers. So let me pull up this Lambda. Okay, so their concept is very. It doesn't sound very kind of very something new. It should have been there. You will get a feel that it should have been there earlier. But if you look at our function, you see this function over here, and below that you see layers. Can you see these layers here? And currently there are no layers. Now what happens is that let's say we have uploaded one Java file day before yesterday, a couple of days back, and when we uploaded the Java file, it contained all the dependencies. So if you recall our kind of this JD S3 processor function which we created, if you look at this particular file size, code size, it says 8.8 MB. Now what is happening is that inside this particular function, so all the dependencies which are there. So we saw that it contains Maven dependencies because it has to really go into S3 bucket. So it will have S3 related dependencies. So this particular function it is also putting all the dependencies. See, behind the scene it is going to run as a container. So when it is going to run as container, it requires all the dependencies within it. So this is something 8.8 MB. If you look at another function, because I deployed it again, processor new function. And if you look at this, it is again saying 8.8 megabyte. So what is happening here? All the dependencies, see, code there is hardly change. And code file is not 8.8 MB, it is like in KB. That code file is slightly modified, but every time I upload a new function, then all the dependencies are again uploaded to the Lambda. Though those dependencies are common. So this was the case some time back. So this was resulting in a lot of duplication in Lambda code and so on. So what Lambda said, we will give you a feature where we will introduce concept of a layer. So what layer does, basically layer is nothing but you just deploy the code, the dependencies only once, and then this Lambda function can import another layer. So that is the benefit of the layer. So let me see if I have this. Let me. Okay. So this is something which used to happen. Like, we did this. If you don't use layer, this happens. So function 1 is having dependency 1, dependency 2. Upload the function. Then in Lambda, it is going to get these dependencies again. But I'm going to create a layer. So what is I'm going to do? I'm going to create a layer saying dependency layer. And I'm going to add all the dependencies over there. So it is simply a zip file which contains libraries, custom runtime, and you can have up to 5 layers per function. And total dependency code size is less than 250 megabyte. And I can just upload it once. And then once the layer is uploaded, then your code size which needs to be uploaded, it will not be 8.8 MB. It will be something like maybe in few KBs. And when the function runs, so let's say your function 1 is running, and there are multiple layers. So layer 1, layer 2, layer 3, layer 4, and layer 5. So all the layers, all the dependencies which are there in the layer will be downloaded at runtime. So it goes to a specific folder called opt runtime, and every kind of dependency is unzipped over there. So that is the mechanism of this layer. So which you should actually use it when you are working with kind of all common dependencies. Don't include all the functions with all the dependencies because it is going to increase the code size as well. So your deployment cycle is going to also increase. So you have to upload the bigger size code to Lambda service. And then it has to be downloaded. It has to create one container and so on. A lot of backend processing which happens. That's the benefit of layer. So one more point is called accessing Lambda function within our VPC. So if you just go back to our kind of demo document, and let's say if I just look at the picture diagram. All right, so this is something which is our kind of structure except EFS share. And we also added one database in our environment. So if you just recall whatever we have done so far on AWS infrastructure side. I just scroll down. Okay, so if you look at this particular picture, then we have a public instance, we have a private instance, and also we have database. And we have also seen how to create database, how to connect to database. We also saw how to run one container-based application. Now, if you looked at our API gateway and Lambda, then what I could do, I can also provide similar functionality. So what I can do, I can create a Lambda function, and that Lambda might run over here. Let's say Lambda will run, and Lambda will needs to access our database. But there is a important distinction when you are actually want to use the resources which are in your VPC. This is our custom VPC. So by Lambda does not have a permission to actually connect directly to this database. Now, if you ask me why, that is the way it has been designed. So whenever the Lambda runs in Amazon VPC, and you can go to the internet without having internet gateway and so on. So you don't have to really create entire VPC altogether. So Lambda does not run inside the VPC by default. That may not be actually secure for many applications. And in case if you want to access your databases, which is running in the private subnet, then you have to configure your Lambda to run inside the VPC. That is what the Lambda VPC configuration is there. So what you could do, you can write code in Lambda function. You can say that I want to connect to MySQL. So you will write all MySQL related code and try to hit to this database through Lambda. But unless you configure your Lambda to run within VPC, it cannot work. So that is something which is configured in Lambda. So what happens by default, Lambda function is not configured to connect to your custom VPC. So this is our Lambda service VPC. This is separate VPC altogether, which is not our custom VPC. But if your database is running in private subnet, then you cannot access it. Elastic cache is something known as caching service. That also you cannot access. If you want to access private services which are running in private subnet, that is also not possible. So what you do, you have to configure Lambda function to use your VPC. So just ignore this on left hand side. This was for the guys who are using a VPC for earlier days, since earlier days. But currently, the way it works is that our customer owned VPC is there. So when you configure your Lambda to run in VPC, it is going to create something known as VPC to VPC natting. Natting means network address translation. It is going to create an elastic network interface, and through which it accesses our database code behind the scene. Now you don't have to really go into the integrities of what are these behind the scene, but if you want to access your resources which are running in private subnet, then you should configure your Lambda, and that is where VPC comes into picture. So currently it is not there, but if I just go to another function which is in my account, then I have configured something known as VPC setting here. So what it says is that I'm going to use my VPC, which is demo VPC, and I'm going to use these subnets. So what is going to happen, that particular elastic network interface will be created in one of the subnets, and through that our invocation is going to happen. So this is only required in case if you want to access your private resources, could be database, could be elastic cache or private services. Otherwise, Lambda do not have access to your custom VPC. So that is something which you should remember. So what you could in fact write Lambda code and just connect to the database, because from coding perspective, there is hardly any change. The only thing which you should remember is that you should not do a lot of file IO using Lambda, because that is something which is not recommended. All right, so that's about this couple of points on Lambda. So we will switch back to our this EC2 configuration and so on. So we need to understand a couple of points here related to like EC2 and something known as elastic load balancing. So if you look at our kind of model, Now this model will work seamlessly as long as there is no significant load. Just imagine that you have an application which is expecting or a significant amount of search. Then let's understand this model from now high availability point of view and from scalability point of view. It might happen that your CPU utilization on this instance might actually hit around 70 to 80%. It might happen that your database is kind of throttling. It is not accepting more connections. So let's focus on one aspect, which is, let's say this particular instance is not sufficient enough to handle the load. Then in that case, how you are going to address this situation? So whenever you deploy an application, your solution architect or somebody who is responsible for defining the solution on AWS, they might say that I want to use something known as load balancer and I want to use multi-node configuration. So what is going to happen? I am going to say that I want to create a different model altogether. So I'm just going to simplify this here. So I'm not going to put all the elements here. So let's say we have this VPC here. And we have one public instance running here. Another is not running. Another is running as private. So I'm just going to small this one pub. And then another one is private one. Okay. So this is one EC2 instance. And just imagine this is a VPC. So what I'm going to do, I'm going to introduce one more node. So I'm saying that one node cannot handle my load. So I'm going to introduce one more node. So this node is going to be my new node. Okay. So this is my new node. So this is my EC2 instance. And then I'm going to introduce one more element which is called elastic load balancer. So what I'm going to do, I'm going to create something known as elastic load balancer. And what I'm going to say, now my application will be configured in such a manner. It is going to internally use this EC2 instance as well as this new one. And whenever the users requests are coming, those will be, for one request will go here, second request will go here, third will go here, fourth will actually go here. So this way you can distribute the load across two EC2 servers. And this model is called horizontal scaling. So that is something which we are going to understand how to set this up. Horizontal scaling. So when you go with horizontal scaling, each instance will be running the same software, the same application on it. So whenever the request comes, it should kind of segregated to two multiple nodes. If you find there are additional kind of load, even if these two nodes are not sufficient, then in that case you can add additional nodes. So I can go on additional nodes. So I will create one more node. Okay, one more. Create one more. One more. You can create as many nodes you want. But that is something which you don't want to create manually. So if you don't want to create that manually, then that is something which can be configured. So these nodes can be configured in something known as auto scaling mode. So this particular configuration, when the automated instances are automatically kind of added to this, is called auto scaling. So its system automatically scales. Now scales on what criteria? So you can put up a criteria. If my CPU utilization is greater than equal to 80%, then please trigger this auto scaling. and then it is going to add one node here, another node here. So this is called scaling out. So this term is called scaling out. And you can also put another condition because it is very elastic. You can say CPU is, let's say, less than equal to 20% for, let's say, 10 minutes. Then I want to destroy the servers. So this is called scaling in. So I'm going to scale in my capacity because I don't need additional capacity, because whenever you are running additional instances, you have to really have those instances running, and ultimately you are paying for those. So today we will just look at elastic load balancing and how it works. And currently we have one, in our EC2 instance, there is only, I think, one public instance which is running in our custom VPC. And we have two things which is installed. One is simple HTTPD. And second one is something which is running as a Docker container, that is, I will just say register app. Now it is also possible that you can use the same load balancer and you can show the appropriate page depending on something known as path URL or path, or it could be host headers. So we'll also see those, how to actually set it up. I will explain about host header later. So this is the way typical your configuration is going to look like in a real world if you are expecting a significant amount of scale to your servers. So we are talking about only scaling the web front end. Now, if you are having, let's say, read application, read heavy application, then we have seen RDS has one feature. And one RDS is something known as read replica. If you remember, for read heavy application, what we can do, we can set up our database in such a manner that I can use one database and I can create multiple read replicas. So I'm basically just showing some read replicas. So this is again from the scaling perspective. And this application, let's say these all these kind of will be connecting to these particular databases. So this is like for read and write. So you will actually reserve it only for writing. This is only for read operations. Okay. So this way you can really think about scaling your underlying infrastructure if there is an infrastructural issue. So that is the way typically the scaling model works in AWS. So that is something which we are going to configure, but we'll just configure load balancer just now. So let's go to AWS console. So if you are trying this along with me, so if you go to EC2, on the left hand side, you will see load balancers. Now in my case, there is just one load balancer, but I'm going to create one more. So let's create a load balancer. Now, when you create a load balancer, there are different types of load balancers. One is called application load balancer, network load balancer, and classic load balancer. Now there are certain kind of distinction differences. So classic is previous generation. So nowadays we don't use classic load balancer. It operates at HTTP, HTTPS, and TCP. So this is called layer 4, which is the TCP layer, or layer 7 model. because HTTP is layer 7 model. So it can work at both the layers. Whereas network load balancer works only on layer 4. So it supports UTP, it supports static IP addressing, and it basically is capable of handling millions of requests per second. So that is something which is very interesting. It can support millions of requests per second. So it's very, very highly scalable, but it is operating at layer 4. The application load balancer, when you need a flexible features for your web application like HTTP and HTTPS traffic, if you want to do request routing, if my domain contains, let's say, register.johndeere.com, it should go to one application or one EC2 instance. If it contains, let's say, maybe a tractor.johndeere.com, it should go to another server application. Then you should use application load balancer. So it provides something known as advanced routing features. So it is very handy when you are working with microservices and so on. So let's create an application load balancer. And if you are in doubt, generally most of the people are working at the HTTP layer. So always create application load balancer. Create it. Again, which is very configuration heavy. So we are going to configure load balancer. Let's specify some name. So I'm just following my naming convention. I say Amod, then JD, ALB. So ALB is for application load balancer. And then I'm going to say whether it's internet facing or internal. I want this to be internet facing because my external users should be able to access my load balancer. If it is internal, then the external traffic cannot access my load balancer. So I go back to my load balancer setting and I say listener. So load balancer is what? Load balancer is something which is going to be an additional component. And on this load balancer, some listeners are running. So that is a listener. So my load balancer is listening on port 80. So what I'm saying here, so this load balancer. So this is something which is listening on port 80. So there is a listener on this load balancer. See, we are not configuring a load balancer on EC2. This is a managed service. So there is a listener. So listener is listening on port 80. So behind the scene, Amazon is going to, AWS is going to create one EC2, which is not visible to us. But in fact, it's going to use some EC2 instance. And the listener is listening on port 80. And then I have to configure this load balancer in a specific VPC. Since we have created our VPC, I'm going to use demo VPC. Not demo, sorry, JD VPC. And you have to create this load balancer and you have to choose 2 subnets from each AZ. I will shortly explain what is the reason for it, but you have to choose at least 1 subnet from each AZ. And for that, I'm going to use public subnet in each AZ. Those who are following along with me right now, ensure that you choose the public subnet in both the AZs. Otherwise, our test will not work. So we want to verify our instance is reachable from this load balancer or not. So that's it. We create this. So load balancer, what happens behind the scene? The load balancer itself, you will see that load balancer is called elastic load balancer. Because the load balancer itself should be elastic. Otherwise, if the load balancer becomes a bottleneck, that's a big problem. That is why we need to have these 2 subnets, because it can actually spin up additional instances behind the scene for us. It is only for the load balancing purpose. So now is the next configure instance setting. It is possible to install HTTPS certificate on load balancer. If you are having a domain, if you want to have a custom domain, let's say johndeere.com, and if you want to use HTTPS, then you can do that as well. Now next, configure security group. So we are going to create a new security group. because typically when you work with load balancer, I want to keep my load balancer with some security settings. So I'm going to have one more security group here, which is my ELB security group. So this is different security group than our EC2 instance. So let me create that. So go back to console. So I'm just going to say Amod JD ALB SG. And which traffic I want to allow port 80, and I want to use it for anywhere because this is a public facing load balancer. And next is configure routing. So load balancer is getting the request, but to whom it should route. So there is a concept of target group. So what happens behind the scene? Let's say there are many instances. So what you can do, you can say that I'm going to have a target group. So I can group these two instances as one target group. So these two instances, I am saying this is my target group. So target group is typically per application. Because on my EC2 in our case, let's say we have two applications. One is called register app. Second is HTTPD. So I'm going to say I want to create a target group which is pointing to HTTPD. HTTPD is nothing but simple Apache. So I'm just going to create a new target group. See, right now we are having only a single instance. So other instance we have not created so far. So let's go back to console. I say new target group, Amod JD TG target group. And what is a target type? So I want to target it to instance, but also you can specify to Lambda function and so on. And then protocol is HTTP, port is 80. And then health checks. So what is health check? See, load balancer is going to get the request and it is going to send it to only healthy instances. How does it find healthy instances? For that, it has to do health check. So health check is nothing but simply put, it is going to send one request to this instance at every defined frequency. And if it finds a response from that, then it is going to mark that as a healthy. But it basically should get the responses for n number of times. So if it gets a response, let's say once at time t1, it got success. It may do it like 3 times, 4 times, 5 times. Then only it is going to mark that as a healthy. But if it is going to say that for one request it has got success, for another request it did not get a response, then depending on your setting, it will mark that as unhealthy. So whenever the request comes to load balancer, the request will be routed to only healthy instances and not to unhealthy instances. So I go back to this one and I say AT health checks. I keep protocol HTTP path is okay, fine. That's default path /. And you can also configure something like advanced health checking. Healthy threshold 5. It means it should get 5 consecutive successful responses from the underlying host, underlying EC2. Unhealthy threshold true. The number of consecutive health check failures required before considering a target as unhealthy. Timeout. So if it does not get any kind of response within 5 seconds, it will be flagged as failed health check. Interval 30 seconds. So at every 30 seconds, the ELB is going to initiate one request to our EC2 instance. And success code is 200. So that is something which I'm going to create now, new target group. And target group is created, but you need to add these target groups to registered target group. So what I'm going to do, in my case, I am already having one instance which is I've started sometime back. If you don't have any instance running, then you will not see anything over here. So ensure that you start your instance and then you add this target to this target group later also. If you and is and so it says successfully created load balancer. So let me go back to my load balancer. So it is going to take some time because it is provisioning. See, we don't have to create any physical machine and then set up load balancer, buy hardware. It's all, everything is software defined here. And then on the left hand side, you will have target groups. And here I just created one target group just now, which is Amod JDTG. And it should contain at least one target, and I will wait for some time to become healthy. So what is happening? I have created just one instance and I just added this to. So currently HTTPD is having only one instance. So anyone trying, then just ensure that you have this up and running.
Can you please repeat what you configured in the configure security groups section? Like
Okay.
what permissions did you there?
So security group, I just said HTTP 80 and allowed to all. It's open to all. Somehow this new UI is bad actually. It's like, can you see this?
Yes.
So you have to just say edit inbound rules. Whatever is wherever you are, if you're configuring that, you have to just say anywhere. All right, I think let's take a short break. So right now it is 16:04. Let's meet at 16:20. Yeah, I will see you after 15 minutes. Do you want to see my screen still? I can keep it on. I think, shall we start?
Yes.
Yeah, all right. Okay, so we have just created the load balancer. So let's see what is happening with load balancer now. So those people who are trying along with me, just go to target group and see whether what is the state in the target group. So the targets needs to be healthy. So if I look at my target group and there's only one target, the target is showing me as healthy. And this will show healthy only when something is running on this port 80 on the server. Yes, any question? Any issue? Okay, so if it is in healthy state, then how should I access it via the load balancer? Because now it is running behind the load balancer, and how the load balancer in target group is connected. So if you look at the load balancer, this load balancer is created, and load balancers give you some information like ARN, Amazon resource name. It also provides you a DNS name. And this DNS name is globally available, publicly routable. So it is active. And if I go to listeners, it is listening on port 80, and this is forwarding to this target group. So by default, it goes to that particular instance. So let us go to this particular DNS endpoint and let's see whether it works or not. So if I'm going to my DNS endpoint, all right. So if you look at my DNS endpoint, I am running from EC2 JD workshop. Now this is something which we have not configured on load balancer per se, but this is actually on EC2. Because if you remember earlier kind of last week session, where we configured this HTTPD, and it is running. So anyone getting similar output?
Yes.
Is your load balancer working?
Yes.
Yes. Okay, good. And also on the instance, if you follow the Docker instructions, and I believe my Docker also should be running there on port 8080. Now, if I go to port 8080, through load balancer, it is not going to allow because the listener is not running on port 8080. But if I go to my EC2 instance, my EC2 instance is having a public IP. So I will just verify. So on that particular EC2 instance, so I will just go to my public instance. This is my public one. So I'll go to this public IP. And let's see if I go to my 8080, what should I get? So probably my Docker is not running over there. So I need to check. So I will connect to my EC2 instance and verify that shortly. But this is the concept of load balancer. So we have not added any additional, there is no load balancing happening per se because there is only single instance. But this model is more secure. So what happens is that our instance is in the subnet but I can configure this in such a manner that only external traffic is allowed to its load balancer, and then I can configure this so as to accept traffic only from the load balancer. So that is also possible, and this should be done typically in the kind of production environment. You should not expose your web server directly to the outside world, because in the load balancer you can add additional features, something known as web application firewall, by which you can put additional rules and you can control the traffic in much secure way. And also you can put a certificate. If you have a domain, then you can put it on load balancer. In fact, AWS provides you certificate manager through which you can get a certificate free and set it up on load balancer. So if you have your own custom domain, then you can really get everything set it up within AWS itself. You don't have to go to any third party to get SSL certificate and so on. So that is the functionality of load balancer and how to configure load balancer and how it works. So let me check, what is happening with my other Docker container. Then Docker container is running or not. So what I'm going to do, I'm going to connect to my public EC2 instance. So this is my instance. So let me copy this. Go to my terminal window. I say connect. And if I look at my Docker PS, looks like I installed it on some other instance, it seems. One second. So this is running in so let me see if I having Docker here or not. I was expecting Docker should be there because I might have configured that on different instance altogether, because on that day we ran some Docker containers. So I'm just setting up my Docker container once again on this particular instance. So I need to start a Docker service. I think I did not do that. So my Docker is there. Then I need to. I can just run one command. Okay, so I'll just do sudo. And you must have kind of, actually seen in practice that how quick it is to actually install Docker and set up an application. That is the benefit of Docker. Otherwise, I have to really download my Tomcat and set it up on this particular server. So fully it is there now. Sudo docker ps. So now port 8080. So let me see now what is happening here. Port 8080. And also that the port 8080 has to be kind of, there on EC2 instance. So I need to check that EC2 instance. So you'll realize that once you set this up in a more secure way, you need to change a lot of things. But that is the way it is done. So I'm just going to execute. I'm just going to say all traffic is allowed. So it is exposing on port 8080. I'm sure I'm going to the same IP address. So all traffic is allowed. TCP. So I'm just trying to modify my security group. So just say anywhere. So realize that there are a lot many settings in AWS. So if you are running with a very secure environment, then you might have to do many changes. So this is running in my VPC. If I look at my inbound rules, it is allowed. So what could be the potential issue here? Anybody? Since you learned about security groups, learned about VPC. What could be other issue here? Anyone? So where should I check elsewhere? So those guys who are trying with Docker container, are you getting the same thing, or it's for you guys it's working?
For me, it is working. I just created the Docker again because it was not on the public domain. It was on private when we
Okay.
have created ID. So I created again.
Okay, fine. I am expecting this to work as is. Looks like demo gods are not happy today.
So do we need to check into the VPC also, where we means private and public VPC, where there also we have means put some security rules, right?
Yes. But if you look at this curl localhost, at least I should get this page from the outside world because because
Yes.
it is saying not connecting to server. But it is giving me output. Strange. So these are kind of a typical problems you will encounter when working with AWS. And I think I just need to localhost 8080. Strange. Right. So I think it's some issue. I need to debug further. So everything looks to be okay. So the potential issue could be, if you look at our diagram, the potential issue could be your security group. That is something which you enabled. The other issue could be our network ACLs are also configured correctly. So I don't see any reason why it should not work, but I still need to debug it. So this is a security model. So security group could be an issue. Internet gateway is there. Otherwise, I will not be able to connect to EC2 instance. And I'm connected to public instance. So let me check one more thing and then we'll proceed further. So I will restart this instance once again. Let's see what happens. It should not be an issue because all the ports are kind of allowed here. HTTP, 8080 is allowed. One more point, I may not have mentioned this explicitly, but if I'm going to stop my instance, so you will notice if you note the public IP here. Now it is stopping. Let's see what is happening with public IP. So what will happen? Public IP will remain or it will go away. What will happen? Anyone?
It will get changed.
Yeah, it will get changed or it will just go away. Okay, it will just go away. So if you look at this, as soon as I stop my instance, this public IP is gone. And this is called dynamic public IP. Because when I'm going to start my instance again, I will get a different public IP. So I'm starting. And after some time, after a few seconds, look at this. I got this IP address, which is different. So this is called dynamic public IP. And when you have a dynamic public IP, this might be a challenge in some of the cases. So if you need fixed IP, then what is the solution? Those guys are familiar with AWS. What is the solution? If you want to have a static IP.
Elastic IP.
That's correct. So you have to use elastic IP. There is a concept of elastic IP in EC2. Let me see whether it's working here. So it is still kind of starting up. No, it's not working. So I have to check. There might be some local settings. I don't know what's the issue. But ideally, I'm expecting that to work because it is working over there. So elastic IP is something which is static IP. So on EC2, you will see one section called elastic IP. So it is called elastic for a reason. Currently, there are no elastic IP. I can say allocate elastic IP. And this is a static IP you will get. So I'm going to allocate. And it gave me 15.2020746, something like that. And I can attach this IP, associate this IP to my instance. So I want to check this. I want to connect to this instance, and I say associate. Now, as soon as I do this, this is IP address is associated with an instance. So I can copy this IP address. If I go to my browser, then I will get the same result because it is connecting to the same EC2 instance. So this is called static IP. And what is the benefit of the static IP? So this is called elastic IP because let's say EIP is it's allocated. So this is EIP. So EIP is associated with one EC2 instance. Now this is fixed. So I'm just going to say hypothetical 1.2.3.4. Now in case this EC2 instance is like running your application and something goes wrong on this EC2 instance, it is not working. So this is basically kind of issue, some issue with this instance. So this is gone. So your application end user will also kind of suffer because this is not working. So what you can do, you can spin up one more instance. So you can create one more instance and this is your new instance. And what you can do, this elastic IP is associated with this instance. Now you can associate to another instance. And on this particular instance, you will install the same application. So in that case, by using this IP or this static IP, even if there is an issue behind the scene, that will not be kind of visible to a lot of users who are using this IP address. So that is why it is called elastic, because you can take it away from one instance and attach it to another instance. That is called remapping elastic IP. And what is the how does it? It is not free per se. For example, if your elastic IP address is associated with a running instance, so this is running. In that case, you are not paying for this instance. But so for this, the charge they are going to be $0. But as soon as this goes into a stop state, and if the EIP is still associated, then you have to pay for this particular configuration. So you pay for static IP as long as it is you don't pay anything as long as it is associated with running EC2 instance. That is something which you should remember. So if you are allocated in elastic IP, then ensure that it is associated with running instance. Otherwise, you will spend up some money. All right. So I'm going to so that's about this load balancer. So I hope you got the load balancer concept. We will look at some other features of load balancers as well as auto scaling subsequently. All right, so I think we also created one AMI sometime back. So let's look at one more feature of which is called auto scaling. So let's understand auto scaling a little bit. So this is the same thing explained over here So you can have multiple load balancers, and then you can have multiple instances. Okay. Yeah. So if you want to have a pictorial view, that is what something which we have discussed and also looked at. So we created load balancer as a listener, and then just now we created one target group and also associated with health check. So tomorrow we will see how to actually add additional target groups so that we can see register app over there. Now let's understand this concept of auto scaling. So let's understand why do we need auto scaling and what are the challenges associated with it. So I think this is one popular event. So finally the IPL is going to happen, and this is a very popular event. And what is the characteristics of this event is that, as well as something like Formula 1. So a lot of people will actually watch IPL. They do watch IPL, and like people watch live. People will actually look at scores and so on. So these events are something which is highly kind of popular event. And if you are just think about imagining or building something catering to this kind of events, it could be as simple as just displaying the scores, or could be building some kind of messaging application. Even if you look at building a score, then also you will get lot many hits on the kind of website so as to see what is going on. So you need the underlying infrastructure, and in fact you will see that you must be watching this IPL over Hotstar. So Hotstar actually runs on AWS. So this IPL and everything is actually running from AWS infrastructure, and they spin up lot many EC2 instances also. So again, in I think in 6 months, they spin up around 4 million EC2 instances. So that was basically spot instances. So just imagine the kind of kind of volume which they are having. So Hotstar basically streams everything. So they may not be necessarily using CloudFront, but they are heavily using AWS. So you'll find some sessions on YouTube also how they have achieved that. So it is worth taking a note of it. The other nature is viral. So something goes viral. So this is not something which is planned. These are actually planned events. So you can plan around those events. So this event is going to start, let's say on next month. Then you know that when to increase the capacity and so on. But when something goes viral, how do you take care of it? Because it is not something which is planned. And if you're familiar with something known as Pokemon Go, so there used to be a game. I don't know whether that is still available. So people used to take the mobile phone, and it was augmented reality based phone. So what you do basically just take the phone, and your job is to find Pokemon. So Pokemon will be shown somewhere. So you point your mobile phone, let's say to the outside. Let's say you are in, let's say Magarpatta city. They will say, okay, Pokemon is at destination center. So what next you do? You take your mobile phone and go to DC, and then you point your mobile phone. And if you find Pokemon there, you might have to tap on the screen, and then you will get some points. And then the Pokemon will actually go somewhere else. It will go to maybe like another mall which is nearby. And then you go there. So it may go to Pune station also. And you just follow that Pokemon Go. So that was something which was a game, and that game became very viral. So in that case, how do you actually address those scenarios? Then familiar cases, Snapdeal. In fact, Snapdeal was running on AWS some time back. I'm not sure what is the state. Flipkart and Amazon. So these companies, Amazon definitely runs on AWS. So sometime back around I think around 2015, something like that. So Flipkart had planned one big event, and they had deployed nearly 5,000 servers and had prepared for 20 times the traffic growth. And what happened at that time, that they did not anticipate so much kind of traffic, and people actually got a lot of different weird kind of things. So they said that I want to add this to shopping cart. Then when they went to actually check out, the item was missing from the shopping cart. Somebody got very expensive items at very significant low rates. So a lot of things actually went haywire. So how do you actually address those scenarios? So one of the kind of solution could be to use auto scaling. And in that case, auto scaling can enable you to cater to the significant amount of load, provided you configure it kind of correctly. See, I'm just simplifying this from the capacity perspective, assuming that the capacity is not enough. But in most of the cases, we know that the capacity is hardly a problem sometimes, or many times I would say. Most of the time, the problem is in your application architecture, application design, or the code. But assuming that application code is fine, design is fine, and I really want this significant huge capacity, then the auto scaling will come into picture. So that is something which we are going to see. And if I just go back to my particular dashboard. So here, if I say that currently my load balancer is using only one instance, but I want to auto scale it. And auto scaling might be required because there's a planned event. Let's say IPL is a planned event, Formula 1 is a planned event. So I know that this is going to happen at particular scheduled time. Or if it is viral, then you have to have a different mechanism like this. CPU more than 80%, please trigger my auto scaling. So let me go to this console again. All right, so we're going to look at auto scaling. So the way auto scaling works is that I will just explain through the slides itself. One sec. Okay. Yeah. All right. So there are three things when we work with auto scaling. So one is called auto scaling group. So it's a logical unit for scaling and managing. You say minimum size, you specify desired capacity, and you say maximum capacity. And what happens when you configure this along with some additional settings, VPC subnets, in which we subnet it has to run. What is the metric on which it has to trigger? So that is something which you can configure. And it is going to trigger whenever there is it meets that kind of particular event, or that, let's say it's a scheduled event, it is going to trigger at that time. If it is based on capacity, it will actually use something known as CloudWatch alarms. So that configuration is required. And then you have to also specify what is the template for instances. So that is called launch configuration. So which AMI should I use? What should be the storage? What should be the security group? What is the key pair? So all those things need to be configured. And then finally you say, what is my scaling option? Tell me when to and how to scale, whether it is based on occurrence of event, dynamic, or it is scheduled. So all these configurations are actually done so as to ensure that auto scaling works in a proper way. So there is no magic here. The magic is happening only somebody is monitoring it and then triggering it. So all things are actually set up to this configuration. So let's see how to actually work with this auto scaling group and also understand some of the nuances of actually working with this scaling. So for this, we have to create one security group because there is an issue or there is a defect somewhere in the EC2. There's a launch configuration and so on. So what we are going to do, we are going to use a specific security group which I want to use for my auto scaled instances. So I'm going to go to my VPC, or I can do it from here itself. Go to security groups. And I'm going to create a security group which is required for my auto scaling. Let's say create security group. So I'm going to say auto scaling Amod JD auto scaling SG. And I'm going to create this in VPC. This is my JD VPC. And I'm going to keep everything open for the timing just to avoid any debugging. And I'm going to keep all traffic. And I say anywhere. And I say create security group. Just remember the security group name. So this is my security group name. Amod.jd autoscaling SG. All right, so that is something which I created, and I will go to autoscaling section. On the left hand side in the EC2, you will see autoscaling section. So let's say I create launch configuration. Now launch configuration is something which provides an AMI. So if you go to launch configuration, there are some launch configurations are already there, but I'm going to create a new one. Let's create launch configuration. If anyone is following, just let me know so that I can slow down if required. So I'm going to create launch configuration. So I'm going to follow all the naming convention which I'm following. So let's say this is my JDLC launch configuration. And whenever you are using launch configuration, you need to specify AMI. Now we have created a custom AMI earlier, so I'm going to use the custom AMI. And I will see custom AMI as with my name. And what is the instance type here? I choose an instance type. So I'm going to keep all things tiny. So I'm just going to use T3 or T2 micro. You can use T2 nano also, but T2 micro I'm going to use. One vCPU and one GB memory. So vCPU is nothing but it's a kind of, if you want to compare the relative capacity of CPU in EC2, you can really use vCPU. It basically translates to one thread per. It translates to one thread. And I'm just going to use T2 micro. And there is also you can request spot instances. If you remember the spot instance, which gives you heavy discount, but it also gives you 2 minutes termination notice. That is something which is also possible. Then I'm just going to keep EBS volume as 8 GB. And I'm going to select an existing group. So here ensure that you select an existing security group which I just created, or whatever security group which you have created. So there are a lot many security groups here. So I'm just want to switch to because our security groups need to be in the same VPC. So let me see what is the security groups which I created. So in that case, the naming convention is pretty handy. but if you see, otherwise it is going to be a bit cumbersome to find out. Okay, so this is my security group. Okay, so just going to copy this. Okay, so this is my security group. Select my security group. And then I just say, what is my key pair? In case if you want to log into ACT instance, I'm going to use my existing key pair. I say demo KP. And I say acknowledge that I have access to the selected private key and create launch configuration. So if you remember, this is similar to your EC2 instance launch, but here we are not going to launch our instance manually. So we are going to decide, basically can rely on this auto scaling configuration. So this is step number 1. So I'm basically created this, I created this one LC. Now I'm going to create auto scaling group. So I select my launch configuration and I create an auto scaling group. So launch configuration do not specify, what is the minimum, maximum desired capacity. That is something which is specified over here. Auto scaling ASG. Launch configuration, I'm going to use the one which I just now created. Then you click on next. You say where this is getting used. So I'm going to say network is going to be JDVPC. And where this instance should be launching. So I'm just going to select the subnet. So I'm going to select public subnet 1A. Then you can say next. Now what I want to do, if I refer to my picture, then I want to set up this behind the load balancer. So whenever this instance is created, it should go inside the load balancer. So that is something that association has to be made. So what I'm going to say, enable load balancing. And I'm going to, so this is my target group. So that is something which is added, and I'm going to keep all the things as default. So what we are saying that, please add this to load balancer. Say next. Desired capacity is equal to 1, minimum capacity is equal to 1, maximum capacity is equal to, I'm going to say 2. That is maximum. Okay, so that is, I want to keep it maximum. Scaling policies. Right now it is none. So you can also keep target tracking scaling policy. I'll just shortly talk about that. Click on next. I can also add notification. I'm going to skip and I'm going to move to next. I can add tags. So I'm going to say tag is name. So this is something which will get added to instances. So I'm going to say Amod, Kadam, JD dot instance. So this is like auto scaling instance. I'm going to say auto scaling instance and click on next. So what am I saying? Desired capacity is equal to 1, minimum is equal to 1, and I create auto scaling group, fingers crossed. So what is happening right now? We have created launch configuration and auto scaling configuration. So it is updating the capacity. So if you look at this, so I'm going to select this one, and it is updating capacity. And if I look at my activity tab here, If I look at this one, it is launching a new EC2 instance. So if you look at this one, it is creating new one. So if I look at my instance ID, it's ending with 466. And if I go to my EC2 dashboard, let's see whether I can see that instance here or not. And you will see here one instance has come up, or it is still in process because it is initializing. If you look at this, it is initializing. It is initializing, and it has also given us public IP. So let's wait for a few minutes, and it should be up and running. So if I go to this IP address, see what is happening. So if I go to this particular IP address, now I am getting the same web page because I am using the same AMI. So if you are trying it, let me know if you got this or not. So this auto scaling, what it has done, it has created new EC2 instance. And our web page, basically we are using the AMI, which was pre-configured earlier. So whenever you are working with EC2, and if you want to use auto scaling feature, then you should create a custom AMI. That is recommended because this AMI typically should contain all the applications, OS plus app and plus any kind of configuration. That could be one approach. And whenever this is AMI is used for launching an EC2 instance, all the things are readily available. And that is the reason why we are getting this HTTPD page when we use this instance through auto scaling. So it is successful. And if I look at my, let's see if everything is fine, then I should see one more instance in my target group. Look at my targets. And my target group contains two EC2 instances. One is through auto scaling instance, auto scaling configuration, and another is through manual configuration. So this instance is created that is not through auto scaling lifecycle. So this is the way you could actually scale. So if you go back to our example or hypothetical scenario, the Flipkart was trying to spin up, or they had spin up only 5,000 instances. But you could actually using auto scaling and setting a trigger using scaling policy, you could just go on adding additional nodes. You could have scaled to like 10,000 nodes also if required. 5,000 itself is a big number. So if so, that is the way this auto scaling works. And there are some nuances, so we'll understand those also. Now this is something I have just set it up. And let's say if you terminate an EC2 instance, let's say if I terminate this EC2 instance, then what will happen? If I terminate this EC2 instance, then what will happen? Considering auto scaling into picture now.
I think nothing means application will run because it has basic main instance, right? It's just added one.
Yeah, that's correct, because we have added like we have two instances behind the load balancer. So even if this is terminated, it will work. But what is going to happen because of this auto scaling? Auto scaling has a minimum and desired configuration. So what I will do, let's see this in action. I'm going to terminate this. So this could be termination, this could be health check failure, this could be the other reason why this load balancer is not, or auto scaling is not able to maintain that desired capacity. So what it is going to do is that let's look at auto scaling group configuration. What has happened now? So this is like, you could say it's simulation of something, health check, or it could be literally somebody is going to delete that. And if I look at my activity, so what I'm expecting, because my auto scaling is configured with minimum desired capacity, this should spin up a new EC2 instance. Because my desired capacity or minimum capacity is equal to 1. It will always maintain the minimum capacity. So right now, it will take some time to actually trigger that. So it is not going to trigger, it is going to wait for some time, because there is also concept of cooldown period. Otherwise, if the instance is terminated and the auto scaling starts once again immediately, then there might be challenges in some cases. So I'm just going to wait for some time. Let's see what is happening. So it is not instantaneous, remember. It takes time because we are talking at the VM level. So this is a VM level scaling or an EC2 level instance level scaling. And if you recall our discussion on Docker containers, whenever I said I want to spin up additional Docker containers, I ran it pretty quickly. I ran it like, say Docker container run Tomcat on different port and just ran it fairly quickly. And that is why the Docker containers, that is called container level scaling. This is what we are looking at is EC2 level scaling. So let's see what is happening in my dashboard. We'll come back to this. I'm expecting there should be one more instance created by this auto scaling group. So what are the implications of this? Now let's go back to our presentation. Now this is the auto scaling life cycle, instance life cycle. And so what happens when you actually create an auto scaling group and you specify the configuration? It basically, if a scale out happens, then it is going to start an instance. The instance goes into pending state, and from pending it goes to in service state. See, when the instance goes into pending state, from pending to in service, it might actually take some time because the instance need to be launched. Then if there is an application that needs to be kind of started, it should be up and running. So it takes time, and after that it is basically in service. And let's say a scaling event happens, or if somebody terminates it, there is a health check is happening, then it is going to scale in. Then it is going to terminate the instance. So when the instance is terminated, it's gone. So remember one thing, that whenever you are working auto scaling, the instances are always created new and terminated. Instances are always created new. You can't just say that I want to use auto scaling, but instead of adding the instances, I want to scale up. I want to increase the size of the instance. Now, that is something which is not possible with auto scaling. So once you look at this life cycle, you will see there are some challenges. All application developer should actually ensure that whenever you want to instance to be actually using or be used in the auto scaling, don't do any kind of stateful kind of logic on the instance. So you have to really mention, you have to ensure that you are not, ideally you should avoid session affinity. So you should basically, your application should be designed so that the session data is stored somewhere else in the distributed kind of memory. And there could be challenge in the same set log files, because if each server is having, let's say, a server like Apache, JBoss, Tomcat, there are some log files. So when the instance gets terminated, you will actually use the kind of log files. Now that is not something which is very convenient for many applications. So Amazon gives you one hook. So when the instance is in terminating state, you can write a hook. So the control will be actually passed to you, and then you can basically do whatever operation you want to do. Typically, copy the log files to maybe S3 or put it on DynamoDB, something like that. And then once you are done, then you have to say terminating proceed, and then the instance will be terminated. So this gives you some kind of control over termination, but you cannot really hold it forever. So I think there is a window of 1 hour. If you don't respond within 1 hour, or if you don't say terminating proceed within 1 hour, the instance will be anyway terminated. So this is for termination. Similarly, whenever the instance is actually created, you might want to do some kind of automated scripts. You want to run some automated scripts so as to configure application correctly. And you can basically say that it takes a little bit of time. It may take 5 minutes. Then also in that case, you can configure, this is something known as lifecycle hook for PC instance launching. And once that is configured, you can basically say, please proceed. And then the instance will actually go in service mode. So that is the way the auto scaling works. And it will try to maintain this minimum size as we are trying to see this. So let me go back to my console. So if you look at this instance now, so look at this now, it has created one more here with different public IP. So this is something which is it will always try to maintain that. So if I go to this particular instance, so this was my earlier public IP. Now I will get different. I got different public IP. Come here and just check. So we got the response. So this is the way the auto scaling works. And any question?
Yeah, so means that means when we apply auto scaling, then the instance which is created through auto scaling never get terminated. Means whenever we try to terminate it, it will automatically get recreated.
Yes, basically what happens when you terminate it, the instance will get terminated. But it is going to create another instance, because it will always maintain that minimum capacity.
Okay. And what if we are sufficient with our original one, means after having auto scaling, and we don't want that minimum one also?
Yeah, then what you should do, good point. So what you should do, you should change the auto scaling group and make everything 0. So I will come here and I say edit. If you see desired capacity here, minimum capacity, and if I make minimum capacity is equal to 0, desired equal to 0, and just save, then what will happen? It is going to terminate all the instances which are started by it. So auto scaling will terminate all the instances. So it will be 0. Got it?
Okay.
Yeah. See, we have seen this auto scaling in action. So, but we have not seen automatic scaling. No, there are various policies by which you can actually do this. So in the interest of time, I'm just going to explain one, and then we'll look at scheduled action policy. So if you look at this one now, now if you look at this updating capacity, you've seen this updating capacity because my desired capacity is now 0. And if I go back to my EC2 instances, I will see that instances might be in terminating state. Go to instance dashboard. So it is updating, but after some time you will see this instance will be terminated automatically. So we'll come back to this. So let me go back to my auto scaling. So when I look at my auto scaling group, let's look at the scaling policies. Okay, so you can always check what activity is happening over here. See, if you look at this now, there is another, okay, fine. There is one more concept which is called waiting for ELB connection training. So what is happening is that it has launched one EC2 instance, and I am connected to that EC2 instance through browser. Look at this. Now I'll close this. Now there is a concept of known as connection draining. See what is happening whenever you terminate an EC2 instance through auto scaling. The auto scaling is not going to terminate it automatically immediately. So it is going to wait for some time because whatever the connections are actually pending, it has to actually proceed and complete that connection request. And since typically we are looking at HTTP, we don't wait for minutes. So I think seconds are more than enough. 1 second, 2 seconds. But it allows you to wait for some time. So it is going to wait for, I think default is 5 minutes, something like that. And if it doesn't get any kind of it is not going to accept any further request because now it is in terminating state, waiting for ELB connection draining. But this current request will be served, and then after that it is going to terminate. So if you come back here and refresh the screen, you will see it is basically the status will change to terminating. So there have been a lot of changes to this UI of late. So automatic scaling. So I can create a scheduled action, or I can also create a policy. Currently, no scaling policies are currently specified. So I can say I want to add a policy. So one simple policy is called target tracking policy. So what is target tracking? Target tracking is very simple. So it says that if I say I want to maintain my CPU around 80%, and if there is like, so I say that please do whatever it takes to maintain my average CPU utilization to be 80% or less than 80%. So if I come here and it's average CPU utilization or let's say 50. To be on safer side, it is on higher side. In practice, typically we'll keep like 60 to 75%. If I say do whatever it is to keep my average CPU utilization around 50%, and I say create. So what is going to happen? It is going to set the policy and assume that there is a lot of load on the instance. Then if the load goes beyond 50%, then it is going to trigger. It says add or remove, take the action. Look at this one, add or remove capacity units as required. So if the capacity goes beyond 50, it is going to add the instances. And it has added one instance. Now it has got two instances. Afterwards, again the CPU utilization gone beyond 50%. Then it is going to spin up one more. So it will do whatever it takes to add or remove the instances. So this is called target tracking policy. So this is one very simple policy. So let's see what is happening with activity. Look at the activity meanwhile. So it has terminated. So if I go back to my EC2, refresh this, that instance is gone. So currently I have only two remaining instances. And I can set up this automatic scaling. So we have looked at scaling policies. You can also create different types of policy. I can create one more policy. It's called simple scaling. Now, simple scaling is basically you can create a CloudWatch alarm. See what you can say. This is something you can specifically say based on various metrics. We have not looked at CloudWatch, but typically this basically works with CloudWatch. And you can say that whenever there is a CPU utilization goes beyond 65%, then add one more instance, something like that, as a select metric. So if you look at, we'll look at CloudWatch later. So I'm saying per instance metrics. So this is my, just for hypothetical example, I say this one, select metric. So I selected wrong metric, I think. So if I select auto scaling, this one. We select EC2. Yeah, and if I look at my, let's say, CPU utilization, and I can say trigger this when the CPU utilization on this instance is statistic average period for 5 minutes. is greater than equal to, let's say, 60%, then you can add an auto scaling action. So again, there are various configurations. We are not going to go into all the details of this. The point is that you can create these kind of metrics and you can set up your auto scaling policy. See, now if you look at this one, so let me go back to this auto scaling. So that is an example of another type of policy. And one more example is called add policy, which is called step scaling. Now, step scaling is something which is very kind of interesting. So I'll just explain as a concept what the step scaling is. So step scaling says if the load on my instance is between, I'm talking about CPU utilization only. The load is between 0 to, let's say, 60%. Then basically I don't have to do anything. So do nothing. It's fine. But if the load is between 60 to 80%, I'm going to say add one instance at a time. And if I say now if the load increases further, so I'm going to say if the load is more than 80%, please add 2 instances. If load is greater than 90%, see, we are adding these instances. But what is happening is that even after adding the instances, the load keeps on increasing. Then in that case, what you can say, I'm just going to say add 4 instances. So this example is called step scaling. Because depending on the step where you are basically can not only add, you can also remove the instances. That is also possible. This is called step scaling. So depending on your requirement, you have to really understand the scaling. And when you work with AWS, when say people are learning AWS, you have to really understand these key concepts and how you can leverage. The whole point is that you should actually minimize the manual thing which you are doing, because otherwise, if there is a significant load, if somebody says, okay, the load is increasing, please add one more node. So we are going to go to the console, log into the console, start an instance, create an instance, set up an application. All those things is time consuming, and it is not also, unless you are using automation, it is not something which is repetitive in the sense, you cannot really guarantee that it will work. So once you actually configure this auto scaling, then it should just work so seamlessly. So that's basically that these are 3 different types, and one more type which is called scheduled action. So let's look at the scheduled action. So again, if the nature is viral, if the control or the load on the system is unpredictable, then you should use this kind of thing. And if the load is like unpredictable, at the same time it is scheduled, or it is scheduled and predictable, in that case you can use something known as scheduled action. Yes, I'm just going to delete this so as not to all right, so let me go to automatic scaling and I will start creating a scheduled action. So scheduled action is, let's say, an IPL event. So I'm going to say, just imagine that this is a Hotstar and they are basically doing this. So when the event starts, so typically, like event is starting at 4 o'clock. they will do this at 3:30 or 3 p.m. Let's say IPL start event, scheduled action, and they might say that my desired capacity is now 100. Minimum is 2. They'll say minimum is 20. Maximum is, let's say, 1,000. Something they can actually do it. But for our example, I'm just going to say desired capacity is equal to 1, minimum equal to 1, maximum is equal to 1. And what is the recurrence? I'm going to say this has to recur only once, but you can also do this every day, every week. So let's imagine that you have configured something like a daemon or a batch processing daemon on your AMI. So whenever new instance comes, it basically starts the process. So if it is like regular activity happening like every 1 month, every week, then also you can use auto scaling. Not only that, even to maintain a single EC2 instance, I want to maintain always one instance. In that case also, you can use auto scaling. It is not purely for scaling high scale kind of internet scale activities. It is just to maintain the desired capacity and minimum and maximum capacity and so on. So I'm just going to say once. Start time, let's say I want to start it today is 27th. These times are in UTC, so I need to check what is the UTC time, and I will say current time in UTC. So it's 12:07 p.m. current time. So I'm just going to 12. Let's say 10. So create. So scheduled action created or edited successfully. Now if I look at my AC2, I'm having only 2 running instances. No, none of the instances are actually started by auto scaling. These are called on demand. On demand have a different life cycle than auto scaling. Because when you talk about auto scaling, we just saw it basically just comes to the life and terminates. But on demand, you can stop it. So I will just go to my auto scaling configuration. And let's look at what is happening with scheduled action. Automatic scaling, scheduled action. So start time, let's see whether it's properly or not, 5:40. So it is going to trigger at 5:40. So current time is, I think we have a couple of minutes, I believe. Now remember one thing, whenever this instance comes up, your application has to be available. And how do you ensure that application is already available? So that is called something as AMI design strategy. You look at AMI design strategies. Because you can always bake your AMI with all the full-fledged application. So you can put your OS, you can put OS is anyway there, you can put your software configuration like Apache, Tom, like JBoss, any other kind of some configuration. And then your application is also loaded. So that is something which is called fully baked AMI, because AMI contains all the kind of softwares, and sometimes it is also known as golden image. So let's see what is going on, whether it is started. It has not started yet. Yeah, so somehow the UI is not that great. So how do I come to know whether the schedule action started or not? Because it just vanishes from here. That's not the great way of actually understanding it. And if I look at my EC2 dashboard now, It takes time to reflect all those things. It is not instantaneous. But it will maintain the desired number of capacity with, see, look at this. If I refresh my screen again, now this is basically spun because of our scheduled action. So that is the way our EC2 auto scaling works. I'm just pausing my screen sharing for a minute. Any questions so far on this? All right, so let's proceed further. So if you are actually doing this along with me, ensure that you, after this session, ensure that you change the EC2 auto scaling configuration so as to keep everything 0. Otherwise, your instances will be running. You are still able to see my screen, right? Can you see AMI design strategies?
Yes.
Okay. All right. So when you talk about auto scaling, then we have this something known as AMI design strategies. So this is something which you need to understand, because this will actually decide what is the strategy which you are going to use in your solution. So on the left hand side, we have this bootstrap. Sorry. So on the left hand side, we have this fully baked AMI. So our operating system is there. Then application runtimes are there, and the application as well. Now this is one strategy. Now the current model which we have used in our application or demonstration is this is called fully baked. Everything is there. Now this is something which is very useful when you are trying to use this in the auto scaling world, because when your auto scaling comes, auto scaling is required just to take care of the load. So if the auto scaling is going to take a lot of time to spin up instance, and on top of that, if your instance is not pre-configured, then it is going to take additional time, which is not really great for auto scaling scenarios. So on the right hand side, you have another strategy where you say that I want to use just enough OS AMI. So what happens in this case, you don't have all these things apart from OS, you're just having a bare minimum thing, OS. Then all the security, monitoring, logging, application runtime like framework, application, and everything is installed at runtime dynamically. So when the instance is launching, instance is running, it goes into running state, and then there might be some pre-configured initialization script. So which might actually go to maybe some Docker container hub. It might go to some Git repository. It will download all the application and set it up. So it takes time. So this is called dynamic at launch. So what is the benefit? So on the right hand side, you see this is very kind of, you don't have to create lot many AMIs. So if there is a patch, then ideally this configuration really works for patching. For major releases, you should always have fully baked AMI. But for patching and every day, if you're doing release, every night release, then this might actually really work. Because whenever you create an AMI, this AMI gets stored in S3, and you will be actually charged for those storage elements also. So these are kind of two primary variants. So on the right hand side, the flexibility increases as you go towards left. Flexibility decreases, but the simplicity increases. And then you can decide, then these are two different combinations, hybrid AMI. So it is up to you, what configuration you want to keep for dynamic and what configuration you want to keep static. When I say static, it is baked inside the AMI. So this is something which you should be aware, and your AMI should be actually designed in such a manner. So as a general practice, create AMI for major releases like R1, R2. If you are doing patching, then you might decide dynamic and so on. But if you are having auto scaling, then always it's recommended to use something known as Bootstrap. All right, so that's about this auto scaling, the core concepts. So once you understand this core concept, then you can explore various other features of auto scaling. So I think important concepts we have covered. And if I go to my auto scaling group, just ensure that you do this setting. If you are not, otherwise, your instance will be always running. And even if you terminate, auto scaling is going to start your instances. So what I'm going to do, I'm going to create one more scheduled action. I can also create one more scheduled action. So I'm going to say create scheduled action, and I say this could be session over action. Desired capacity is equal to 0, minimum 0, maximum 0, recurrence once, and do it today. And what time it is? If I look at my current time in UTC, it's 12:18. So I'm just going to say maybe by 12:30, something like that. Or I can do it 12:25. Create. So at 5:55, my instances will be actually terminated. Ensure you do this, otherwise it will keep running. All right, so all these things are really essential when you are working with auto scaling. And there is something, one more service which I will introduce, and then we will do the lab tomorrow. See, whatever we have done so far, so we have set up kind of a lot of infrastructure. So a lot of elements are actually running in AWS. Now there is one more service which is provided by AWS, which is called Elastic Beanstalk. So let's look at that. So let's look at the concept. So Elastic Beanstalk, or also called EB, it's a PaaS offering for deployment, monitoring, and notifications. Now, what is PaaS offering? PaaS offering is called platform as a service. Now, whatever we have seen so far in AWS is predominantly IaaS model. When I say IaaS, it is infrastructure as a service. So when you talk about PaaS, so in the PaaS model, what happens is that you generally are not really keen around managing the infrastructure. So whatever examples which we have seen so far, I say that I just want to deploy my application. I don't care how do you monitor it, how do you deploy it. I'm interested in service. I just want to run my Tomcat container, or I just want to run this WAR file. And I don't want to, go into all these nitty-gritties and in all the complexities of managing the infrastructure, starting from setting up the VPC, maybe like setting up different subnets, setting up security groups, setting up load balancer, setting up auto scaling, setting up launch configuration. So that is something which I don't want to really monitor, or I don't want to really, worry about creating those things. So in that case, you can look at something known as Elastic Beanstalk. It's a PaaS offering for deployment, monitoring, and notifications. It handles the deployment details of capacity provisioning, load balancing, auto scaling, and health monitoring. It's an easier way for developers to quickly deploy and manage web application in the AWS cloud without worrying about nitty-gritty of AWS. So this service is primarily targeted towards developers. Now again, see, AWS has grown from kind of startup ecosystem. That is something you should always bear in mind. What are the genes or actual growth? So you will look at this, so a lot of companies who are starting up, they're not worried about CI/CD pipeline. They don't have anything. They are not worried about processes. They just want to get it quickly up and running. They are not worried about whether it's configured securely or not. They just want to get it running, because even if it fails, there is not a significant risk. They can always redo it. So typically such companies started adopting Elastic Beanstalk, and eventually it got mature enough so that enterprises also started using this one. Fast and simple to use, increases developer productivity because you will focus on application functionality. Because nowadays developers have to do many things. You have to develop the functionality, you have to deploy the application, and nowadays people are moving to a DevOps world also. And that is something which is kind of adding a lot of kind of pressure to developers, saying that you should do this, also monitor this, and so on. So how to kind of move away from that is using Elastic Beanstalk. Even if you're using Elastic Beanstalk, you are still retaining the full control of underlying resources. So behind the scene, it is going to use all the elements which we have seen: EC2, ELB, auto scaling. But if you want, you can really modify it also. It is integrated using it is integrated with IDE. You have to just upload the application. You can straight away use console and so on. So there are something which is very different than typical PaaS service providers. You still have root access to a EC2 instance. Now, if in case of RDS, you cannot have root access because RDS is a managed service. You can easily manage configuration changes in one place. You can use any database, RDS, SQL Server, Oracle. There is no constraint per se. You can create custom AMIs. You can use custom AMIs. You can run other services side by side in EC2. So it's not something which you have to only use Elastic Beanstalk. And you can easily move your application out of Elastic Beanstalk. No lock-in. Now you should note that this is not a programming framework, which is typically, if you go to with, like if you want to use Google App Engine, then most likely it will work in Google. If you are using something on Oracle Apex, then it is going to work only on Oracle. But not the Elastic Beanstalk. Elastic Beanstalk is not a programming framework per se, so there is no lock-in. So you can still use Java-based application, Tomcat, you can use Docker, you can use .NET, and you can still use Elastic Beanstalk. And if you don't want to use Elastic Beanstalk, that's also fine. You can just move away from Elastic Beanstalk model and set it up yourself. So it's a very simple thing. So it's a create an application. So what happens typically, and I will just quickly walk through the steps. I go to Elastic Beanstalk, And elastic beanstalk is also under compute. See here, elastic beanstalk. So what happens in this elastic beanstalk? We basically create with some kind of an environment, or we basically I want to just create a new application. So new application means like it is an elastic beanstalk application. So I'm just going to say EB app, say Amod JD EB app, and then I say create. And this is my just name. This is just a logical name given to my EB app. And I say create a new environment. And it has got like two environments. We'll discuss that tomorrow. But there is web server environment, select. And it also gives the domain name. And what happens here, I am going to say I want to use something known as a managed platform. So if you look at this one, choose a platform. So here, what happens? You basically just say I want to use Java, or I want to use Tomcat. I can use Tomcat. Then what is going to happen? It is going to say Tomcat platform, Tomcat branch. Again, there are many branches. Platform version, and use a sample application. So I'm going to spin up. So what is going to happen behind the scene? It is going to set up something on Tomcat. So I'm just going to say Amod JD demo. So check availability. So create environment. Fingers crossed. So basically it creates a lot of things. We will go through this exercise tomorrow again, but this will take some time. And if everything works properly, then what is going to happen behind the scene with elastic beanstalk is that it is going to create a lot of things for us. So just to illustrate that, so let's say if you want to install a Tomcat application. So what you will do, assuming that it is running in a VPC, so you launch an EC2 instance. Okay, so this is my first step. Launch. Second is you will connect to it and then set up my application. Let's say in this case Tomcat. Third is you will basically set up your application. And fourth, if you are using VPC and if it is running behind load balancer, then you will configure your VPC, you will configure your ELB, you will configure all the auto scaling, configure launch configuration, and then all those things are done by you. So when you use elastic beanstalk, all the things are actually done by the elastic beanstalk platform for us. So what happens in the elastic beanstalk? You say that you specify the platform and you will just specify your application code. So what happens behind the scene? The elastic beanstalk is going to do the same thing for you. It is not going to be different. And it is going to take your app code. Let's say if you're uploading a WAR file, then that particular WAR file will be uploaded to Tomcat's web apps folder. So all the things are done by this platform. That is what elastic beanstalk does. So that is the kind of key concept of elastic beanstalk, and this will help you to deploy your application pretty quickly and fast. So it takes time. It is not very because it is doing lot many things, and it is going to deploy some sample application which might be some sample PHP page and